Here we go. 2-2. Notes linear relations and functions. So we talked a little bit about a relation versus a function in section 2.1. Now we're going to be talking about linear relations and functions. Linear meaning lines. So a linear relation is a straight line graph versus a curved line graph. We need x to the first power and y to the first power. So x has to be to the first power and also y has to be to the first power. So no squareds, no cubes, no divided by x, nothing like that. So if we look at 4x plus 2y equals 6, the question is that linear? Do we have x to the first power? Do we have y to the first power? Yes to both of those. So yes, that's linear. If we look at number 2, the second one there, y equals negative 1/3 x plus 2. Do we have x to the first power? We do. Do we have y to the first power? We do. Remember, these are little imaginary ones there. So both of those are to the first power. So is this linear? Yes, it is. Let's look at the next one. We've got x squared plus 2y equals negative 7. Do we have x to the first power? We do not. We have an x squared. So is this linear? No. Who fails? Who's the failure on this one? The x squared causes it to not be linear. This is actually a quadratic equation. And let's look at the last one here. 2x plus 3 divided by y equals 1. Is this linear? No, because this y is really to a negative 1 power, not to a first power. So no. Who's the failure? The failure term is the 3 divided by y. A linear function, f of x equals m times x plus b, where m and b are real numbers. So we define a linear function to look like this. F of x, remember that's our function notation, equals m times x plus b, where m and b are real numbers. What does m represent? M represents the slope. And what does b represent? B represents the y-coordinate of the y-intercept. Remember, intercepts are points that cross either the x, or the points that lie on either the x or the y axis. Oh, sorry, I jumped the gun. What's an x-intercept? It's a point on the x-axis. It'll be, the point will be x comma 0. And the y-intercept is a point on the y-axis. That'll always be of the form 0 comma y. We are asked to find the x and y intercepts quite often, and I'm going to tell you right now, I'm going to be picky about the notation. Very picky. Intercepts are ordered pairs. You need to write it as an ordered pair, not just like the x part, not the y part. I need it as an ordered pair, x comma 0 or 0 comma y. So let's look at a few more linear functions here, or things that we pretend are linear functions and decide, are they linear? We've got f of x equals negative 2x plus 7. Is that linear? Yes or no? You can think of the f of x kind of as being a y. Okay. Is the x to the first power? There's our little imaginary 1. Yes, it is. How about the second one? Is this linear? Linear? Yes or no? Thumbs up for yes, thumbs down for no. What do you think? No, correct. This is not linear. Who fails? The 3 over x term. Oh, and I just realized I have this or part here. Let's go back to number 1. So yes, it's linear. If it's linear, what's m, what's b? So m is the coefficient on the x, so that's negative 2. What's b? B is the constant 7. Since the second one is not linear, we don't need the m or the b. Let's look at the third one. F of x equals 2xy minus 5. Is that linear? What do you think? Yes or no? No or yes? No is the correct answer. So why not? Who is the failure? What term is the failure? The 2x times y is the failure. We have an x to the first and we have a y to the first, but we have an x times a y, and that's not allowed. And the last one, f of x equals 1/2 x minus 9. Is that linear? Good. Yes, it is, because that's an x to the first. What's m? M, again, is the coefficient on the x. That was the 1/2. B is the constant, -9. Good job. All right. Evaluate a linear function. So we can use linear functions quite often to represent real-world situations. Here's one. The growth rate of Bermuda grass is f of x equals 5.9x plus 3.25, where f of x is the total height in inches after x days. If the grass is 50.45 inches tall, how many days has it been since it was cut? So f of x is the height, and x is the number of days. So this 50.45 is the height, how tall the grass is. So that represents our f of x, because f of x was the height and x was the number of days. So here we'll have our f of x is 50.45 equals 5.9x plus 3.25. We're looking for how many days, so we're looking for the x value. So I'm going to grab my calculator here. And what are we going to do first? We're going to subtract 3.25 from both sides. That gives us 50.45 minus the 3.25. Let's see, 0.20, 47.20 equals 5.9x. Divide both sides by 5.9, and we get 47.2 divided by 5.9 is 8. So x equals 8. Whenever you have a word problem, always label your answer. So in this case, it was 8 days. That way then we know what we're talking about. All right, standard form of a linear equation. So we have a few different ways that we can write linear equations. One of them is standard form. Standard form looks like ax plus by equals c. Seems easy enough. However, there's a lot of rules about standard form. A, b, and c have to be integers. So that means no fractions allowed. No fractions allowed. That's messy handwriting. What else? A has to be greater than 0, or could be 0. So that means if you have an A, it can't be negative. And the A and B are both not 0, because then you would have 0 equals some number, and that just doesn't make sense. And the GCF, greatest common factor of A, B, and C, has to be 1. So you can't divide every term by some number. So if we look at the first one, 2x minus 4y equals 7. The question is that in standard form? It is. Okay, we've got the x, we've got the y equals the constant. A, b, and c are all integers, there's no fractions. The a value is greater than 0. And a and b then are not both 0. And the greatest common factor between 2, 4, and 7 is 1. So here's a case where a is 2, b is -4, and the c value is 7. Let's look at the second example. Is this in standard form? Let me leave those rules there for a second. No, it's not. We have the x and y on the same side, so that's good. The problem is that we have a fraction, and there's no fractions allowed. So we have to get rid of the fraction. How can I get rid of a 1/2? I'm going to multiply by the reciprocal. I'm going to multiply by 2. When I say I'm going to multiply by 2, I am going to multiply everything, every piece, by 2. So when I distribute the 2, 2 times 1/2 will give me x. 2 times 3y will give me 6y equals and the 2 times the 2 will give me a 4. Now it's in standard form. The GCF is 1, there's no fractions, the x and y are on one side, the constants on the other, and a and b are both not 0, and the a value is positive. What's a? 1, that coefficient out front. B is the 6, and C is the constant on the other side, 4. Let's look at number 3. So number 3 is not in standard form because the x and y aren't on the same side. So first thing we want to do is we want to move the x over to the proper side. That gives us negative 3x plus 2y equals negative 1. No fractions, so that's good. Problem on this particular one is that we have a negative for the x. The x cannot be negative, so we're going to fix that by multiplying everything, both sides, everything by negative 1. So when we distribute, we'll get a 3x minus a 2y equals a positive 1. Now it's in standard form, no fractions. The x is positive, the GCF is 1, so a is 3, b is negative 2, and c is 1. Intercepts. So I told you that I want you to write your intercepts as an ordered pair. And I also told you that I am picky about it. And I am. If it's not written as an ordered pair, you will not get full credit, guaranteed. Remember, the x-intercept is always x comma 0. The y-intercept is always 0 comma y. So let's find the x and y-intercepts of these two problems. These are my last two. Okay. So what do I know about every x-intercept? I know that the y is equal to 0. So I'm going to replace the y with 0. That gives me 3x minus 0 equals 6. Divide both sides by 2. I get x equals 2. Therefore, my x-intercept is 2 comma 0. To find the y-intercept, I'm going to do the same thing, but now my x is going to be equal to 0. So I will have 3 times x, which is 0, minus 2y equals 6. That's negative 2y equals 6. Divide both sides by negative 2. We get y equals negative 3. So my y-intercept then is 0 comma negative 3. We look at number 2, we have this written in function notation. So you may want to think about it in terms of the relation notation where y equals negative 4x plus 6. First thing we want to do is replace our y with 0 to find the x-intercept. So that'll be 0 equals negative 4x plus 6. Subtract 6 from both sides. That gives us negative 6 equals negative 4x. Divide both sides by negative 4. We get x equals, simplify that, 3 halves. So our x-intercept then is 3 halves, comma, 0. Then we're going to do it again for the y-intercept. What do we know about the y-intercept? We know that the x is equal to 0. So we'll replace the x with a 0. That tells us that y equals 6. Nice and easy. So that's 0 comma 6. All right. We will find lots and lots of x-intercepts and y-intercepts throughout this chapter and other chapters too. All right. Thanks so much for listening, and do the homework. It's up there at the top. And have a great day. See you tomorrow. Bye.